Example 1A4, particle A travels on a path such that the radial position of A is given by r equals 5 theta, where r is given in meters and theta in radians. It is also known that theta dot equals 2 radians per second and is a constant. We're trying to determine the velocity vector for A when theta equals pi, and the acceleration vector for A when theta equals pi. To first find the velocity vector equation, one must know r dot, and r double dot. R is 5 theta, which means r dot is 5 theta dot. R double dot is 0. Velocity vector equation for polar coordinates is as such. The velocity vector equation, after plugging in the values, becomes after plugging in your values, your velocity vector equation becomes 5 theta dot e r hat plus 10 theta e theta hat. After plugging in your value for theta dot, the equation becomes and plugging in your value for theta, the velocity vector equation becomes 10 e r hat plus 10 pi e theta hat.
So the next thing you want to do is solve for your acceleration vector. We want to find that at theta equaling pi. So the first thing you want to do is write down your acceleration vector. It's r double dot minus r theta dot squared er hat. And then you're going to add that to r theta dot plus 2r dot theta dot in the e theta direction. Now you pretty much, since we already solved for the values here, we just want to plug them into this equation here. So you're going to get 0 minus 5 theta, and you're going to multiply that by 2 squared. And that's going to be in the e r hat direction. You're going to add that to 5 theta times 0 plus 2 times r dot, which is 5 theta dot, times 2. That's going to be in the e theta hat direction. Through some simplification, your final answer is going to be negative 20 pi in the e r hat direction plus 40 in the e theta hat direction.